What up, what up? What's up, guys? Thanks for visiting. Today we're going to be learning about what are we learning about? Today we're going to be learning about slope-intercept form. So you better have your seatbelt on because we about to go off on this one, y'all. But either way, it's about to go down. What up, what up? I am your teacher and facilitator, D Math Professor. And guys, I'm truly excited because today we're going to be learning about the slope-intercept form. Now, the slope-intercept form is one of my favorites because you see it everywhere throughout algebra. Even when we're talking about function notation, it's really just another funky way of writing the slope-intercept form. So if you get a really good indication, or better yet, an understanding of how to create slope-intercept form equations, then algebra seems to be a bit repetitive if you get that. Don't worry, that's going to make sense a little later on. In addition to today's lesson, I wanted to kind of spruce things up, try something a little different, you know what I mean? I wanted to introduce a new word of the day. And so from here on out, I'm going to be introducing some new words that you can use as part of your vocabulary. Now, some words are going to be easy to use. Some words may be a little more difficult. However, we're going to build this vocabulary together so that way as we do a lot of these word problems, vocabulary doesn't become an issue. The new word of the day is going to be boulder dash. Yes, boulder dash. Say it with me, boulder dash. Now, let's define what this word means and see if we could use it in a sentence. Boulder dash. It means senseless talk or nonsense. Rubbish. Utter ridiculousness. Kind of like how they killed your boy Iron Man on Endgame. I am Iron Man. Bro, that was Boulder Dash. But either way, thank you for your time. Look here. Okay, get it? New word of the day. So, that being said, let's go ahead and do what we came here to do, y'all. Let's get started on this math. Let's go. Okay, today's lesson is going to be on the slope-intercept form. That equation is y equals mx plus b, where m equals slope and b is the y-intercept. So let's look at the first example. It says, write the equation of the line given the slope and the y-intercept. So in this particular case, our slope is -2 and our y-intercept is 5. So we're just going to recreate the equation plugging in these values. So I start off with my y equals, my slope is -2, and I'm plugging that in. I put my x in, which represents my independent and input values. And then I look at my y-intercept and notice that it's positive, so I'm going to say +5 and opposed to anything else. If my y-intercept was negative, then I would write minus. So that's a great way to know whether you're going to do a plus or minus scenario. So +5. So the equation to this statement is y equals -2x plus 5. Great job. Easy enough, right? So let's look at the second example. It says slope is 3/4 and the y-intercept is -3. Same concept. I want to identify my slope and I want to identify the y-intercept because these are the values that I'm going to have to plug in to create the equation. All right. So I got 3/4 as my slope and -3 as my y-intercept. So let's create the equation. Y equals, and then instead of writing m, I'm going to plug in my slope. In this case, it is 3/4. And then we automatically write our x because that is a part of the formula. Now in this case, let's look at our y-intercept. We notice that it is negative. So this is where we write the minus sign and then we put our 3. So y equals 3/4 x minus 3. All right, cool. So now let's check out some other examples where we got to create the slope-intercept form. Only this time we're going to create them from taking a look at our graph. So let's scroll down here right quick. All right, it says write the equation of the line in slope-intercept form given the graph. So we got our graph, but it doesn't change the rule. We need two things, the slope and the y-intercept. And if we could always find those in any scenario, we can create this equation. All right, so let's look at how to find our slope. Now the slope is simply the distance between 2 points. So if I look at my first graph, I see that I have 2 points, 0, -5, and then 3, -1. So the slope is going to be my distance between 2 points. It's kind of like getting directions from one point to the next. You're going to have to be able to find the distance from where you are to where you got to go in order to get there. So let's look at the point 1, right? In this case, it's 0, -5, and it's point 1 because if we read from left to right, it's the first point that we come across. So let's see how many times we have to go up to go from that first point to that second point. Now, I want to bring up a critical point. That second point, 3, -1, sits on a specific line. So I'm going to highlight that real quickly so that you all can see it. And the reason why that's important is because I have to figure out how many times I need to get to this line. And once I'm on this line, it means I'm on the street that this other point sits on. So if I can get to that line, I'm that much closer to the point that I need to be on. So let's count how many units to get from one to the next. Here we go. So 1, 2, 3, 4. So in order from where I was at to where that other point is located, I had to go up 4 units. And the reason why I stopped there is because I'm eventually going to have to now change directions, okay? But I know from where I was to where I need to be, I had to go up 4 units or 4 blocks, right? And now that I'm on the same street, it seems like I'm going to have to make a right, and that's going to cost me 1, 2, 3 units. So I had to go to the right 3 units. So those numbers represent my slope, right? So your slope is going to be how many times you have to either go up and how many times you have to go to the right. Those numbers represent slope. In this case, we went up 4 times and then we went over to the right 3 times. Now, I said all that to say, don't always be surprised, or don't always expect rather to go up and to the right. Sometimes you'll have to go down and to the right. However, the one thing I do want you to lock in is when you go up to the right, the slope is always going to be positive. So it's positive 4/3. All right, so now we need to find our y-intercept. Now that's the easiest one to spot because the y-intercept normally sits on the y-axis. So what I typically like to do is just kind of like zoom in or highlight the y-axis itself. So I'm going to go ahead and put an indicator right here so that you all can see where the y-axis is located. And then what I'll do is go ahead and find the point that sits on that line. This is my y-axis. You could tell it's the y-axis because it has the y there. Now the point that sits there, according to this, is 0, -5. Between those 2 points, that's the only point that sits on the y-axis. Once I find that point, I'm only needing the y value of the coordinate. In this case, it's -5. So my y-intercept is going to be -5. Remember, your y-intercept will always sit on the y-axis if you're looking at a graph. Okay, so now that we have our slope and we have our y-intercept, we got everything we need to create our equation. So let's go ahead and set that up. So according to what I know, we're going to always start off with the letter y, which is our dependent variable, also known as our output, equals, and then the slope in this case is 4/3, so that's what we're going to put. And then don't forget to write your x. That is a part of your equation. Very important to put that input value. Okay, and then we're going to look at our y-intercept. In this case, it's -5, so we put the minus sign, and then we write our 5. So the equation to that graph is going to be y equals 4/3x minus 5. All right, so let's look at this next one. The first point that we come across in this particular case is up here, and we want to take the distance. It looks like we're going to have to go down a total number of, well, remember we want to get on the same street that the second point is located. The second point is 4, -1. So according to this, we're going to have to go down a total number of 2 units, as you can see from the diagram. So we went down 2 units. Now I'm on the same street as my other point, and I got to make a right. Here's a quick tip. We always go right. We never go left. If you ever go left, that's a great indicator that you might be doing something wrong. So we went to the right 1, 2, 3, 4. So we went to the right a total number of 4 times. So now we have our slope. Okay. Remember that when you have to go down, your slope is negative. If you go up, your slope is positive. These are small little tidbits that you can use to kind of ensure that your equation is perfect. So in this case, because we went down 2 units, the slope is going to be a negative 2/4. So let's write that. Negative 2/4. Great. And you know, I have to remind y'all, whenever we're working with fractions, like you were taught way back in elementary, if it can be simplified, simplify it. In this case, it seems like I can simplify this by 2, so that's what I'm going to do. I'm going to divide each value by 2, and that's going to leave me with a negative 1/2. So let's go ahead and write that down. And for those of you all that might be a bit confused as to how I knew I was going to divide by 2, 2 just seems like it can be divided into both of those values. Okay, we could talk more about divisibility rules later. Okay, and then we want to look at our y-intercept. Remember, same rule. I want to highlight my y-axis and find the point that sits there. And according to this, the point 0, 1 sits on the y-axis, and the only thing I need from that point is my y value. And in this case, it's a positive 1. So now I have everything I need to create my equation. Y equals negative, remember it was negative because we went down, negative 1/2, and don't forget to write the x. That is our input value. It's going to come into play later on, trust me. 1/2 x. And then we're going to go ahead and write plus, because our y-intercept in this case is positive, plus 1. And that's how you create the slope-intercept form when given the slope or the y-intercept, and the y-intercept. That's all I got for you guys. It's been real. Deuces.